Okay, let's start with labeling this so that we know that's what this is. Later on we can come back and refer to it. Let me just copy some text over so that you can actually have a reference later on. I will also post these codes for you to actually make use of a little later in my GitHub. Look out for that. So basically this notebook is inspired by how to get an algorithm, how to get an allocation, writing an algorithm for the Quantopian investment management team by Jamie McCorsten. Now the main thing here is that whether you want to be included in the Quantopian investment management or not is up to you, but what this is useful is the process flow that it goes through, and the fact that at the end of it you come up with a long short, low risk, low volatility returns strategy is extremely helpful. So this link is provided for you and you can actually go in and walk through, but in this case what I'm going to do is just to actually cover it in details for you in a separate manner so that you can actually understand how the actual signal itself works. The other blog that they have is access Twitter as well as stock tweets, trader mode data for free, and they also provide speaking opportunity as well. So the first thing that we want to do here is that I do want to import the visualization library. So matplotlib as plt, and we're gonna import pandas for data analysis, and we're gonna import Blaze as vz, import Blaze as vz, and also from zipline utilities we're gonna import the trading calendar and get the trading days. Okay, right. The Psychsignal data is in the form of Blaze expression. Now, why does Quantopian use Blaze is quite simply because of the big data. The amount of data that comes through is far too much to actually compute effectively and efficiently. So they use the Blaze library to separate the database from the computation itself so that the memory doesn't get chewed up too quickly. Blaze actually is very, very similar to pandas. There are some variations, so I'm gonna provide the link for you to actually refer to. I will go through this in another video with regards to the difference between pandas and Blaze. So okay, we already imported stock tweets, so the first thing to have a look at it is let's see what kind of data types it is. So you can see that it's actually a class Blaze expression field. So what do? Stock tweets, use the dot notation and press the tab key, and you can see that there are quite a few things that methods that you can actually make use of, and some of them are attributes. So the first thing I want to do is have a look at what are the fields that I actually can have access to. And looking at this, looks like there's a source, there's the symbols, there's the bullish and bearish intensity. There's actually quite a few things here. So what we're gonna do now is that we're just gonna pull out the stock tweets. So let's just see what comes out when we actually do this. All right, so looking at this, the source is stock tweets, the symbol here is AA, and it tells you the bullish intensity, the bearish intensity, the bull minus bear, basically the difference between the bullish intensity and also the bearish intensity. And you have the bull scored messages, you have the bear scored messages, bull bear ratio. This is actually a ratio, so 1 divided by 0 gives you 0, 2 divided by 1 gives you 2. And the total number of scanned messages is you add these two, gives you 3. The sit is the actual, kind of like the ticker code, but and finally, when did this data come through is as of date, as well as the actual timestamp itself. Now, how do you access this? Probably you're already quite familiar with this now. It's very similar to pandas. I'm going to just show you how to actually get this. So let me just pull this out, bull minus beer. And let's look at the first 5 values. Notice that it works just like pandas, although this is in the form of Blaze. So that makes it a lot easier to play around with. Okay, so the next thing I want to do is just to extract the data. Now I really want it to be completely in pandas because I'm gonna start plotting and manipulating the data. So the first thing that we want to do is create a variable. We call that bool minus beer. We're gonna use a Blaze expression, Blaze, and then compute the stock tweets and bool minus beer. Okay, so store that into the so-called variable BMB. So let's have a look at what BMB, what kind of data type it is. Okay, now it's actually a pandas series. So if we look at the first 5 values, and this is what it looks like. So it's basically a pandas series. And if we have a look at the data itself, and just to see what is the distribution, what are the characteristics, and you can see that there are 10,000 counts. Let's pull this up. The mean value is 0.3644. The standard deviation is 1.16. And the minimum in this case is -4. The maximum is 3.89. Like all data analysis, there are a couple of things that you always want to do is just to visualize your data and just to actually get a feel of what is the distribution, where is the middle of your value. Obviously mean are quite often skewed by outliers, so we just calculate median and see what it looks like. Well, forgot about doing this. So the median is actually 0. Okay, so whereby mean is being pulled up by the actual outliers, the distribution tends to be towards the positive side, quite substantially positive as well. So this is the one thing that you want to actually keep that in mind. People tends to be seems to be more positively inclined than negatively inclined. Okay, although the number here doesn't seem like so. When you look at the minimum is -4 and then the maximum is only 3.89. So it doesn't seem like so, but when you look at the actual comparison between mean and median, it clearly shows that more data are weighted towards the positive side. Right, so let's plot this in the form of a histogram. We're going to give it 50, the bins of 50. Okay, and I don't like these. I want to squelch that line. So if you look at this, it is in essence what we talked about earlier. The median is at 0. All right, remember that. And the actual so-called mean is actually more to the right, so around 0.4. Okay, 0.36. So it's about here. And you can see that this distribution it's heavier on the right side, as we talked about earlier. So this is one thing to keep in mind when you're designing your algorithm. How positive do you want it to be? How high of a positive number, especially when you're considering the distribution, of this data. Okay, so what we're going to do now is just zoom into one stock and just to actually understand how the actual data works. So not unusual. I'm just going to choose Apple. Of course, you can actually choose any stocks you like, but most people know who is Apple or who the company is. So I'm going to create a variable called Apple underscore sit, and the symbols using this is inbuilt API. Okay, so and this is just basically storing the symbols, storing this SID into the variable Apple underscore sit. So if I type this APL sit, and you see that it's 24. 24 represent Apple in this case. So I'm gonna pull up stock tweets, okay, and I want the data to be just AAPL, just Apple only. So this is the pandas method of selecting just that stock itself, stocks tweets. Okay, and we're gonna have a peek. All right, so here we go. You notice that it is all just Apple. Okay, and we're selecting where the SID is just Apple, because we use SID instead of the symbol, because SID is a unique identifier. Symbols may not necessarily be unique, because some company, after being delisted, that same symbol get reused again, and it might not represent the same company. Hence, it's better to actually use SID rather than symbol. Okay, what we can see here is that the source is stock tweets, and we can also see the usual. Earlier, we've already seen this, the bullish intensity, the bearish intensity, the difference between them, the bull score, the bear score, the bull-bear message ratio, and finally the scanned messages. Okay, having done that, we're gonna drill in and see if we can select a date range. Notice that this goes all the way back to 2009 and move forward. Let's just pick a period of time that we want to actually study this. Okay, so let's look at stock tweets, and we're gonna just choose once again Apple. So let me just copy this. Now, because I'm gonna choose multiple so-called selection criteria, the other one is I'm gonna bracket that stock tweets, and the date that I'm interested in as of date, which is this one here. Okay, so the as of date is equals to from 2013 December 1st onwards. Okay, and we're gonna have a peek at the data, underlying data. Again, the same value came up. It is Apple only, and you can see that the date range starts from December 1st, 2013 onwards, as we have actually chosen here. All right, okay, so that's really how you make selection, select a date range to do some analysis. The next thing that we want to do now is just to get a feel of the actual the data itself before we move on to the so-called analysis of the so-called whether the signal that comes through from this database is does have actually a valuable signal that you can actually generate alpha from. So the first thing that we're gonna do, I mentioned earlier, we're gonna look at how many datas are available in here. So the first thing is we're gonna store this number of SIDs, and we're gonna use the Blaze expression and compute the stock tweets itself, and look at how many distinct SID there is, and also count this. Okay, in fact, I'm not gonna just store that. I'm just gonna calculate and let it spit onto the console itself. This might take a wee while. So as you can see, there are 9,228 SIDs in the actual database itself. Your value might be different because they are constantly adding new tickers in there. Okay, so we already looked at Apple a bit earlier. So what we're gonna do now is just drill in and take a slice of Apple's data and just analyze it before we turn it into the algorithm. So now we're going to look at Apple again, except that we're looking at selection of dates rather than looking at all the data. This part is important because we're taking a small slice and reserving the rest for forward testing. In generation of your algorithm, it's always wise to actually keep a portion of your data aside and leave it untouched. You don't want your data, or rather your algorithm that you develop, to actually have the data tarnished or overfitted into the future's data. You take a portion of the historical data, analyze it, design your algorithm along with based on the old set of data or the portion that you put aside for training, and after that you test it on the test data itself. If there are some sort of signal in there, you should be able to see outsized or abnormal profit in the training or in the test data itself, one that your algorithm hasn't seen as yet. Okay, the first thing that I want to do is just create a date mask. This is to actually select the date that we're going to analyze this algorithm, design our data. So I chose 2013 December 1st earlier, and I wanted to just look at a portion of the data that we have rather than the whole lot. Okay, so we're looking at between 2013 December 1st and 2014 December 1st. That's the first one. The next one is we want to look at just Apple. Okay. And finally, we are looking at the stock. Store this into this data, this variable called stock tweets, and during the 2014 period, and we select these data using the normal criteria here, mask and also stock mask, and sort the data by the date. Okay, right. Those are all in Blaze. Okay, so the next thing we want to do is convert this into pandas for visualization. So we need to compute the expression and convert it into a pandas data frame. So we're gonna just take this and call this variable data frame, and we're just gonna biz compute. Already done this earlier, so now you're actually seeing it again. I'll just repeat it a few times so that you actually get the hang of it. So let's just see how long this takes. Okay, it's done. All right, so the first thing is just want to have a look at the data frame itself, just making sure that it is pandas data frame. That's the first one. And the next one that I do want to look at is what kind of data is available. So basically what we have seen before. Okay, so next thing, we want to plot at the x-axis as of date, the date, and the y-axis, we wanted to plot the bool minus the beer. So in essence, we are looking at the difference. So let's just plot this and visualize this, and this is what it looks like. Okay, so this is one way to visualize the data, see what you can actually get the hang of it. So during the period between July and September 2014, there seems to be quite a bit of back and forth splashing around. Notice that the upper end tends to be a bit more than the lower end. Okay, as in the positive end goes all the way to almost 2, whereby the down spike only goes as low as roughly 0.8, 0.9. Okay, so that's the first one. Okay, right. We're gonna move on now. So that's one way to visualize. You can actually repeat this and take any of these fields. Let's just look at the bool intensity and plot that. Oops. Careful when you copy and paste. And so this is the bool intensity. What else can you actually plot? So maybe we can look at the message ratio and also the message ratio. I learned from that mistake. Well, except this time I accidentally removed the apostrophe. So this is the bool to beer ratio. So there's obviously a lot of bullish signal in the early part of January, and there's a lot of bullish signal here during mid-July. And the final one that we want to look at is total scan messages. So let's just see how many messages come through, and let's just put it here. Okay, So there's roughly, have a look at this. This is on one day. The number of messages on that one day around early September is almost 8,000. Okay, so you can imagine how much voluminous data actually comes through. Hence the reason why all of these data are stored in the database, and we're using Blaze rather than using pandas. Otherwise your memory is going to get chewed up, although in this case it's cloud, but it's still not a very efficient use of the so-called memory, computation memory. So that ends the part of just really investigating on the data itself, look at what the underlying of the data looks like and the distribution of it, its behavior. This is just to really explore the data, get a hang of it, get a feel of it. What we're going to do right now is that we're going to move on to the next part, which is using pipeline to define our factor and start developing a long shot strategies just to see if these signal actually have some sort of value to it or not. Okay, so that's the part 2 of what we're looking at here.